So when we talk about peripherals, the first one it comes to our mind is GPIO. So that is the general purpose input output. So in each microcontroller, we have the input pin, so many pins. Any microcontroller or any IC, there are so many pins. So we always make this mark here, so to identify the pin numbers. So it start from here, 1, 2, 3, 4, 5, 6, 7, 8. For example, in this IC, I have only 8 pins. So the most familiar one is for you, IC 741. That is the operational amplifier. Of course, the microcontroller is also an IC. It has a more number of pins. So number of pins, why do we use this pin? This any chip, it can be a microcontroller or operational amplifier or any kind of memory chip. They have pins, input and output pins. So that is how these chips are communicating with the external world, right? So if you want this IC to process any data, you have to give the data to this IC. So then it will take from the input pin, the data. So after process the data, the IC have to give the output. So we are taking from the output pin. So this is why we call this as a general purpose input output pins. GPIO, simply we call this as a GPIO. In any IC, this is the same. We have input and output pins and we are using that. But you should know that in microprocessor or any other pins, these input output pins are fixed. It's fixed because this is a hardware, right? IC is a hardware. So when the designer designed this hardware, everything is fixed. You cannot really change these pin configurations. For example, in IC 741, you have this non-inverting and inverting terminal, and you have the output terminal, right? So if I remember correct, then this is 2 and this is 3 pin number. And yeah, so this pin number is for input. So you cannot change this one. This is fixed. In microprocessor, so you are using a microprocessor in your laptop or in your computer, desktop computer. So this microprocessor also have input output pins. This one also you cannot change. Flexibility is very less, very small. But in microcontroller, it's not like that. This is the specialty of microcontroller that we are looking at. So for example, STM32 microcontroller, it has so many input pins and output pins. You just to go to the data sheet of this STM32. For example, you are using L476, right, in your project. So L476, you go to the data sheet and you will find the pin diagram. So in how many number of input pins and how many, you can see totally how many number of pins are available in this microcontroller. So it has a flexibility. You can set up each pin for what purpose. So that is the advantage of using the microcontroller. So GPIO provides many ways to interface with external circuits within an application framework. So GPIO peripheral is used to configure the device IO port. So technically we call this as a configuration. So I am setting up the input pin or output pin according to what I want. So I can configure. So I can configure the IO ports by myself. So you will see the microcontroller and then the microcontroller have so many pins. I told you to click the left click on the each pin and you will see the list. And then you can click that list, whatever you want to set for. For example, if I have the microcontroller here, so I have so many pins. So each pin will, in the tool, it can be the Cube MX or Cube IDE. In both tools, you will see this microcontroller. So you just, of course, you will see so many number of pins, but I'm just putting, for example, you just left click on this one and then you will see the list of, for example, input, output, and timer. ADC, like that. So you can just click on this particular whichever you want. Then that one will set to this pin. So that is called general purpose input output configuration. Okay, so every IO port implements the logic shown in the image beside. So this is the image taken from this reference manual. So you can see the reference manual. I had given the link. So IO pin is the physical connection to a chip. I told you to external ball soldered on the PCB. So this is just explanation of how the pin is configured on the chip. The link between each GPIO pin and each ball of the package is given in the datasheet. So this is not really important for you. This is about how we are making the pin, because after we manufacture the chip, we need to have the pin that is connected to this inside world of this microcontroller or any chip. So we need to have some kind of small pad. This is the pad which is connecting the pin and this internal part of this microcontroller or any chip. Okay, the read and write accesses allow the processor to configure the peripheral, control the IO pin, and get its status. Yes. So read and write access. So input means what you are doing. You are writing the data inside, and the output means what you are reading the data from the microcontroller. Okay, so alternate function links allow to connect the IO port to an internal peripheral digital line. In such a case, the IO direction is given by the line purpose. And of course, it's really alternate function means what? So input output is okay. Other than that, we have also so many peripherals, like for example, the ADC or timer. These all are peripherals. Why we are calling this as a peripherals? These are extra functions. So this can also be set to the input output pin. So that is alternate functions. Okay, in such a case, UART. So this is also another function. Remember, in some microcontrollers, you can also transmit the data and you can receive the data. It can have an antenna. So at the time, you need to set up one pin as a transmitter and one pin as a receiver. That is also possible in microcontroller. So you can set up the RX pin and you can set up the TX pin. Okay, that is also called alternate function. Okay, so then analog links allow to connect the IO port to an internal peripheral analog line. So you can just read this. ADC is one of the example. So as I said, like in the real-time world, all the signals are analog, but we are giving this analog signal to this microcontroller. Inside the microcontroller, we have the inbuilt ADC, that is the analog to digital converter. It will convert this is ADC. This will convert this analog signal into digital, and then it will process the data, because all the memories and CPU can handle the data only in terms of zeros and ones. So we must need this ADC, analog to digital converter. Okay, so when we write the data, this is the or just a small block diagram. This one, where can you find this? If you go to the data sheet of this, whatever the microcontroller you are going to use, inside the data sheet, you will find this block diagram. So for the GPIO, so during the data write operation, of course, you are writing the data into this bit set reset registers, and then it will transfer the data to output data register, and then it will go to the output control. And then here we have this CMOS. CMOS means what? CMOS means PMOS plus NMOS. Last semester, if you take the course of communication network, I explained about this PMOS, NMOS concept, how we can write the data and read the data and search the data from the memory from transistor level. transistors. These are transistors. So what is the CMOS means? Complementary metal oxide semiconductor transistors. P means that is the P-type metal oxide semiconductor, N-type metal oxide semiconductor. These all are transistors. Okay, so we know 0, if you give 0, then the PMOS will turn on. If you give 1, then this NMOS will turn on. Then based on this, if this NMOS is turned on, then what will happen? This drain and source will get short circuited. This ground will go up here. And then you will get 0 at the output. And if you get, for example, if you turn on this PMOS, then what will happen? This VDD, maybe this is plus 5 volt. So this plus 5, if it's turned on, then this will be short circuited, the drain and source. Then this VDD will travel to this node via this path, because you are applying the gate signal. And after reach this one, then the logic high will drive at the output. So this is the transistor logic. The same logic we are using here also in GPIO. Internally, it's happening in this microcontroller. And we can also set up this each pin in terms of push-pull mode or open drain mode or disabled mode. So it's also possible. As a user, when you configure the pin, for example, I told you here, you can configure the pin. You can also set up this pin can be operated in the push-pull mode or open drain mode or disabled mode. So I will also explain that again, maybe in the next week lecture, I will again explain about GPIO. But just remember now you can set up the pin in the push-pull mode or open drain mode. This is possible in the user interface. In the graphical tool, either CubeMX or IDE, you will see these options. But generally, we keep this as a push-pull mode. This is the default mode we are keeping it. Okay, this is about GPIO. I think you can read these 2 more things. I always suggest you to read the data sheet. That is the one having all the detail about your microcontroller. Okay, so AT multifunction bidirectional IO. Okay, so it has 16 pin ports 5 times. And also each pin can work as a GPIO, general purpose input output, or alternate function, or AF, or external interrupt. So EI. So we have 2 types of interrupt, internal interrupt and external interrupt. So anyway, the pin, you can configure the pin either in GPIO mode or AF mode or external interrupt mode. So as a user, you have all the possibility in the microcontroller to set up, or to maybe setup is not the correct word. Technically, we should call this as a configure. So we can configure the pin in any mode. So in addition, drive C by CS can be configured and bit manipulation is allowed. So mostly maybe you may not use these modes. You will be using only these 3 different modes, at least in this course. Okay, so now this is also talking about the same. How can we apply the control signals and how can we control the output, the same push-pull mode and open drain mode, how this is controlled by this CMOS and so on. So the same thing I explained in this previous slide. And you can also see this table. So we have these, for example, we have the status 00. So it means the pin you are setting as for analog input. And if you are setting the signal status 2 registers, CNF1 and CNF0, if you set up as a 0 and 1 combination, then it will be set as an input floating mode. Floating means it's not logic low or logic high. It's in between, it's just floating. Then we need to use the pull up or pull down resistor to bring it up or to pull it down. So that is pull up. You will use pull up resistor. I mean, you are not using that. You are not the hardware designer here, but normally hardware designers will use the pull up resistor and pull down resistor. So this what this will do, if the input pin or output, if the IO pin is in the floating condition, IO pin, if it floats, float means what? It's not logic 0, it's not logic 0, it's not logic 1. So it's in between. So logic 1 is a 0 volt, for example, and logic 1 is 5 volt plus 5 volt. So this is just near the threshold voltage level. Maybe it's about 0.8 volt or 0.8 volt, and suddenly it will go down to 0.6 volt, and then suddenly it will go up to 1 volt. So it will just keep changing. It will just floating. So in that kind of situations, we need to control this kind of pins. Then we have to use this pull up or pull down resistors, resistor. And then we have to apply the voltage, either make this pin to 0, logic low, or you have to pull it up to 5 volt level. Okay, so and then similarly for this combination 1 0, then yeah, you can set up this pull up, and 1 0, you can also set up this pull down. So it's depending upon how are you going to enable this pull up and pull down resistor. And output push pull, this combination is indicating output push pull also. So these are different bit combinations. It's giving different meaning actually. So here you can see here 0 0 is indicating output push pull. The same 0 0 is indicating analog input. So you may wonder why. You should also know here, this is the mod 1 and mod 0. So here we have the 0 0. So this is the combination together. But here you can see it has a different meaning. So this 0 0 is reserved, and here 0 1 is indicating different clock speeds. Okay, so this is if you look at the data sheet, you will see that, and they also had given the description to learn little more detail about this. But what I want you to remember right now here, GPIO pin. So microcontroller has so many input and output pins. You can configure each pin into whatever the status you want to set up. Okay, so alternate functions, again, I don't go into this, and the external interrupts. So external interrupt can be, for example, here we have 19 external interrupts, 16 are connected to the GPIOs, remaining 3 are connected to RTC, that is a real-time clock. So that is the one you are always seeing, the real-time clock. For example, in your microwave oven in your home, so you see the time. For example, now it's 9:55. You will see the real time. How it's possible? Because the microcontroller is connected to the real-time clock signals. And the USB wake, and then the power voltage detection. We simply call this as a PVD. So in case if there is any power failure, then it needs to be detected immediately. So these all are external interrupts. Of course, if there is a power failure, then it will immediately shut down the CPU, right? So how it's happening? So we have the interrupts. So we are just informing everything. So 19 interrupts, how they are distributed, you can see here, and then each of the 16 external interrupts, how they are connected. For example, here they are connected to any of the GPIO pins and generate an event on interrupt. So all these 16 interrupts are connected to these GPIO pins, but they are not active all the time. So it's really sometimes it will be active. For example, if the timer, we need to activate the timer interrupt, then the corresponding input pin will get interrupted. So on, so on. So these are external interrupts. So here, configure GPIO output pin and input pin within CubeMX tool. So you can try to do this by yourself and configure the input pin to be an interrupt source on the rising edge. So everything is possible in the graphical user interface, the one you are seeing in the tool, and then you can set up whatever the pin you want. I just want you to practice these things so you will practically see how you can set up the pins with a different status. So in your assignments, you will learn how to set up a GPIO pin to be an interrupt pin on the rising edge or falling edge or both edges. So what is this rising edge or falling edge? So for example, I have a clock signal. So clock signal is always, one cycle is one off time and one on time. So from here to here is a one cycle. So this is the clock signal, and you have to set up the pin according to the clock signal rising edge. So for example, the output pin will change in the rising edge, means this is the rising edge. Then the output pin, for example, if you set up as a input pin as an interrupt source on the rising edge, means, so when, sorry, this is the rising edge, then when it meet the rising edge, then it will start to be interrupt source. The interrupt will be enabled. Similarly, if you set up as the falling edge, instead of starting from here, it will start from falling edge of the clock signal. So then the pin will act like an interrupt source from this time. So in both means like either, so whatever comes at first, then immediately the pin will get enabled. So that is the clock signal synchronization. Okay, so that's all about this. And of course, we will write the ISR handler for this interrupt, in which we will toggle on output pin. So if you did the first assignment, you should already know these things. You will toggle the pin, so then only the LED will just change the status. Sometimes it will be on, sometimes it will be off, and you can set up the delay, how long it should be on and off.